Your agent works 9 times out of 10. You tested it, it passed, and you plan to let it run without anybody watching. So run the same task 8 times and ask a different question. What are the odds it gets all 8 right? If those runs were independent, and hold that assumption, it is about 43%, not 90, closer to 4 in 10. Nothing about the agent changed, only the question you asked about it changed. Working 9 times out of 10 is a great score. For anything running unattended, it is also a failing grade. Start with what a score is. Most coding agent benchmarks take an entire run and compress it into 1 bit. Did the task pass? A paper published this July says the quiet part out loud. Nobody using these agents experiences 1 bit. They live the whole trajectory, how it used its tools, and whether it caught its own mistakes. So picture a driving test. Passing once on a familiar route with an examiner telling you when to turn is not being safe to drive alone. Both end in a pass. Only one is a decision you can bet a customer on. This season packed the folder back in episode 1. This one is the last question before you let go of the wheel. Assume you already built test tasks with known good answers. This channel has an episode on that. Now, 2 metrics look almost identical and mean opposite things. The first asks whether at least one attempt out of several succeeded. The second asks whether all of them did. At 1 attempt, they are the same number. By 10 attempts, the first climbs towards certainty while the second falls towards 0. Same agent, same day, opposite stories. And One Frontier Lab's guidance draws the line in a sentence. Use the first for a tool where a person is watching and one good answer wins. Use the second for an agent where consistency is the whole point. And that 43% from the opening? Arithmetic, not a measurement. It assumes the runs are independent. Real ones are correlated, so what you measure is usually kinder than what you compute, which is why you measure. That was arithmetic. This is worse. In June, Cursor published something no vendor is obliged to publish. They built an auditor agent and pointed it at 731 of their own evaluation runs, on benchmarks built from code models we're unlikely to have trained on. The auditor read the problem statement and the full trajectory, without being shown whether the run had passed. Their verdict was that 63% of successful resolutions by the strongest model they serve retrieved the fix rather than derived it. Most of the wins were lookups. In 57% of trajectories, it found the merged pull request or the fixed file on the open web. In 9%, it searched the project's own bundled history for the commit that would fix the bug. The benchmark's maintainers had already sealed that channel upstream, so these runs used older images. Somebody watched the dashcam instead of reading the pass slip. And this is not the contamination story you have heard. This is not about what leaked into the training data. The agent went and got the answer during the exam, so they ran the control. Seal the bundled history, cut the open internet, run it again. The strongest model they serve fell from 87.1% down to 73%. Their own model fell further, more than 20 points, the largest drop in the study. They published that about themselves. Their own caveat travels with it. Gap sizes depend on the prompts you use. Now the point that runs through the rest. A grader is not a referee. A grader is a target. The cheapest route to a passing mark is the route the optimization finds. An evaluation once ended up inside the place its own answers were stored, a story we already told. Measure properly and the number is honest. Almost. Because there is a second axis, nobody puts on a launch page. An academic team published a reliability study this year. The finding is inconvenient for everybody. There are 12 measurements across 4 dimensions, and not one of them is accuracy. Same answer twice, survives a reworded prompt, knows when it does not know, and when it fails, how bad does it get? Across 2 years of model releases, overall reliability shows only small improvements. Accuracy climbed. Reliability barely moved. Every frontier provider clusters in the same place. An industry-wide plateau, not one vendor's problem. And the strangest result, consistency runs backwards. Smaller models are frequently as consistent or more. And the paper's explanation is that a larger model has more solution paths and takes a different one each time. A driver who fails the same move every time is easier to work with than one who fails randomly. That team has now paused its own leaderboard to measure this instead. Now leave the lab. In a survey of enterprise teams published this July, half had already shipped an agent or a language model feature that passed their internal evaluations and then caused a customer-facing failure. For 1 in 4, it had happened more than once. Roughly 2/3 either already allow some production deployment with no human review or are building toward it inside a year. And 5% say they fully trust the automated evaluations behind those decisions. Autonomy is heading toward 2/3. The evaluations behind it are fully trusted by 1 in 20. The survey team is honest about it. 157 qualified enterprise respondents, self-selected rather than random. Read it as directional, not precise. The top reason for that distrust was poor alignment with real-world outcomes, which is the test center car park and the motorway in the rain. Now a word about the grader itself. This channel has an episode on using one model to grade another. Graders fail in both directions. In one lab's own write-up, a model scored 42% on a benchmark until somebody read the grading and found several problems at once. One answer marked wrong was 96.12 because the key wanted more decimal places. Fixed the grading bugs, loosened the harness, and the same model scored 95. On another test, it failed a flight booking task by finding a real loophole in the policy it was given, which was arguably better than the key. So a bad grader punishes good agents just as surely as a weak grader rewards bad ones. Judging a run after it ends assumes the run still exists. In a survey answered at the end of 2025, nearly 90% of organizations had some observability on their agents. Just over half ran offline evaluations. Instrumentation ran ahead of evaluation. There are two very different levels of keeping that record. Agent frameworks typically checkpoint, stating state, so a run resumes where it stopped. A durable execution vendor draws it sharply while selling its own plugin. A checkpoint preserves your data, not your execution. If the process dies, the run dies with it. The infrastructure answer keeps a durable log of everything that happened and replays it to rebuild state after a crash. Anything that can replay a run to recover it can replay it to review it. So, in practice, the recovery log can be the audit trail. Episode 3's logbook survived the shift change. This is the run surviving the crash. So what do you actually do this week? There are 5 moves, most of them from people who publish their methods. Move 1. Start with 20 to 50 tasks drawn from your own real failures, not 1,000 synthetic ones. Early on, every change moves the number a lot. Move 2. Run every task many times rather than once, and report the all runs number, not the best one. Move 3. Score the outcome, audit the trajectory, and never let one pass do both jobs. Move 4. Assume your own agent will find the cheapest route through your grader. Seal the shortcuts deliberately, the way that audit did, and publish both numbers. Move 5. Every failure that reaches a customer becomes a permanent test case. That last one is the cheapest reliability you will ever buy. Now the honest limits. The biggest one is narrower than it looks. A frontier lab warns against grading the path, and it means one specific thing: checking that the agent made the right calls in the right order, because that makes brittle tests. And agents keep finding valid routes the designer never imagined. The same guidance tells you to read the transcripts anyway. So the real question was never whether to read the trajectory. It is what you let the reading decide. And the audit from earlier is the answer in miniature. The only way anybody learned that most of those passes were lookups was by reading what the agents did. And none of this means evaluation has failed. In one study, simple environmental hardening cut exploit rates by nearly 90% in relative terms, and task success did not fall. These are unattended problems, not unsolvable ones. Scope all of it to the middle of 2026, because the standard underneath this is still being written. So carry this shape. A score is 1 bit from 1 attempt on a route the agent may already know. Before you let it run without you, ask 3 questions in order. Does it pass the same task every time, and not just once? Did it pass for the right reason, which you only learn by reading what it did? And will the record of that run still exist tomorrow when you go looking? Then widen what it is allowed to do by risk, not by ambition. Money, customers, and deletions earn autonomy one repeated test at a time. This is episode 5 of Put AI to Work, our season on getting real work out of AI agents, 1 working skill per episode. The full free AI course is on the channel. Subscribe, and the next time an agent passes your test, you will know which question it never asked.